Hey guys, Jay from RS Garage. Today we're going to take a look at a flame hoop gasket system for a 2JZ. As you move up in power, you can get to the point where the deck of the block and the deck of the head distort enough to let that multi-layer steel gasket start to separate. And when it separates, it can become superheated and then it will torch its way out of the engine. So this is a reliable, high horsepower gasket system. It's not new to the market, but it is kind of new to our market. The domestic guys have been relying on it for a number of years now. And unlike using a stainless wire that is installed into the deck of the block or into the deck of the head, the flame hoop is fairly easy to service because the ring can pop up out of the deck of the block or the deck of the head without risking damage to the casting. And unlike the fire ring style gasket, you're presented with an opportunity to create less distortion across the deck of the block, which in turn helps the valve job and the valve train live longer because the valve seats are under less distortion. Optimally, you'd have a situation where you had the maximum amount of sealing with the least amount of distortion. And because the flame hoop is going to be pushing a soft copper head gasket up into the cylinder head, you have an interlocking groove that works incredibly well for high boost operation. Now, because this is a custom racing gasket solution, you have machining involved. The deck of the block needs to be cut for a receiver groove that the flame hoop is going to snap down in. The deck of the head needs to be cut with a receiver groove that the copper head gasket is going to protrude up into the deck of the cylinder head, creating an interlocking seal. Another thing that's important is this flame hoop is not the same on both sides. The bottom side, or the side of the flame hoop that's going to sit down on the block, is square shaped, whereas the top side that's going to protrude into the copper gasket has a radius to it. So you want to get your magnifying glass out and make sure that you're installing the flame hoop in the correct orientation. On this particular engine, we're going to be using a new head stud kit from ARP. The closest you've seen me use a stud like this is with the Mazworks Pro Street blocks, where we have that big 9/16 thread going down into the aluminum and then a 1/2 inch body holding the cylinder head on. This is a 1/2 inch base with a 7/16 top. And much like a tree, what you want is kind of a big root down in the ground and then have this stress coming up the shank of the stud. The cylinder head is going to be expanding and contracting through heat cycles. It's going to be moving around during operation, and you like to keep that stress along the main body of the stud and not hyper-focused in that first thread of the stud. If you take a stud and you put it in the tensile strength machine at ARP and you pull it apart, it's going to fracture at that first thread because that's the most amount of stress. Whereas when you use something like this or an undercut stud, it's an opportunity to spread that stress out along the body of the fastener. That way, as the engine is heating and cooling and the cylinder head is expanding and contracting, you've got some spring to it. So you're not altering the clamp load a lot. You're offering the same amount of clamp load, whether the engine be in a resting state or a working state. Whereas if you use a stud that had a big base ring, like there's some studs out there that have an integrated dowel, and that integrated dowel works well in a main cap situation, but it's not really designed for a head gasket situation because, again, the cylinder head is moving. It's trying to pull up, whereas a main cap is trying to shift left or right. So different hardware for different operation, but the opportunity to grab a 1/2 inch base stud that has a 7/16 body is pretty neat because you're not going to modify the cylinder head to go to a full 1/2 inch stud, and you're also going to have that taper as it moves from 1/2 inch to 7/16 to give the fastener some space to spread that stress out up the shank of the stud. Because the stud uses a bull nose, it's okay to tighten the stud all the way down into the block. I don't have to crank it in there, but I don't have to worry about it rotating because the bull nose is going to bottom in the block and keep the stud from rotating during the installation. We've also made a step dowel to facilitate the installation of the 1/2 inch bottom, 7/16 top stud without having to modify the cylinder head. Now we need to do a dry run or dry install on the gasket. And what we're working to do during this installation is impregnate the flame hoop into the gasket and the gasket into the cylinder head. So we're going to install the cylinder head, and then we're going to take the cylinder head back off, pop the gasket off, then we can install our sealant after we inspect how uniform and concentric the gasket seats into the cylinder head. With the cylinder head on the block, I'm now going to slowly tighten the cylinder head to the block, allowing the flame hoops to push themselves up into the gasket and for the gasket to push itself up into the cylinder head. It's a game of patience. I'm going to do a very small amount at a time and just keep working the cylinder head down until I get it tight. After torquing the cylinder head to 100 foot-pounds, I can now take the cylinder head back off the engine and take a look and see how the flame hoop has impregnated the gasket and how the gasket has protruded into the groove of the cylinder head. Ideally, when you get this gasket to come loose, it will kind of pop loose like that. And you're popping the gasket up out of the groove that's in the cylinder head. And what we're looking for when you look at the relationship between how the flame hoop pushes into the gasket and how the gasket pushes into the cylinder head is an interlocking relationship that's going to keep that gasket from leaking combustion out at high boost. Another obstacle in using a copper head gasket is it needs some sort of sealant applied to the gasket itself. So pick your poison on this one. I'm using a 2-part epoxy. With the cylinder head torqued in place, I still have one more step to do, and that's re-torque the cylinder head after a heat cycle. One of the disadvantages or things you have to deal with when using a copper head gasket is you need to get the engine up to temp, then let it cool back off, and then go back through and re-torque the cylinder head. Sometimes that means running an engine in the car and then pulling valve train back out to torque that cylinder head back up. Or in this case, we're going to use a turkey fryer and a water pump to run near boiling water through this engine, getting it up to 170 or 180 degrees, letting it cool completely, and then going back through the torque sequence, loosening each fastener one by one. So I'll loosen a nut up, I'll reapply the Ultra Torque lube, I'll torque that nut back to spec, and I'll move to the next nut in the order of the torque sequence. You do not loosen the whole cylinder head and tighten it back up. You're going to do one fastener at a time when you're doing a retorque. And this is going to ensure an optimized clamp load across that flange seal and give us a gasket system that if we want to make 1,500 horsepower or 2,000 horsepower, we can do it time and time again and just have a good time with the engine instead of dealing with the shortcomings of a multi-layer steel head gasket or the service issues that you get with a stainless wire or the amount of distortion that you get when you have a fire ring gasket on an engine like this. So there is no perfect solution, but this is damn near close for what the aftermarket has to offer us. Hope you've enjoyed the video. Thanks. Have a good day.